Good evening, everyone, and welcome to Sky Observers Hangout. My name is Michelle, and I am the Director of Public Observing at the Adler Planetarium here in Chicago.
And I'm Hunter, Public Observing Educator here at the Adler Planetarium. Thanks so much for joining us for Sky Observers Hangout tonight. We've got a few folks helping us behind the scenes as well. Here with us in person, our producer, Dylan, off to the side, and a couple folks online today. If you see the Adler Planetarium's name in the chat, that is Bella, who will be helping pass your questions along to us tonight. So let us know if you have any questions, any thoughts on our topics for this evening, and we would love to keep that conversation going. You'll also see Geza in the chat tonight, one of our wonderful astronomy co-workers here at the Adler Planetarium. He will be answering those extra hard-hitting questions, having some really fruitful astronomy-focused conversations in the chat with you.
Well, Sky Observers Hangout is our place to gather together to nerd out about the sky. Our goal is to give you practical tips to maybe find something useful about what's up in the night sky, or maybe something cool going on here at the Adler Planetarium. If you have any questions, please send us your questions, send us your comments in the chat. If you want to just sit back and watch, that is totally fine too, but we love interacting with you. So to start us off, let us know in the chat where you are tuning in from. We'll check back in a minute or so, and maybe we'll give you a little shout out.
If you really like the programming that you see here on the Adler Planetarium, and if you're somebody from Chicago that comes and visits, one way that you can also help show your support is through making a donation to the Adler. So today is Giving Tuesday. We wanted to mention that here today. We appreciate all of you coming here and supporting us by watching the show, but if you want to go that little extra step, Bella will be posting a link for that in the chat today. You can also help us get more visibility for our shows by subscribing to the Adler Planetarium YouTube channel. You'll get notifications not only when we have future Sky Observers Hangout live streams, but also for tons of other content that we put out. Let's say just yesterday, a YouTube short from me all about what's up in December. I think Nick's got a big overview of the winter sky coming up soon. So lots of valuable content on the channel.
And we are open for visits.
Absolutely.
Come and see us. That'd be really fun. Bella can put a link in the chat there about get it to our ticket page, so you can come and see us, and that would be really great. And if you see Hunter and me walking around, just say hi. We love seeing our Sky Observers Hangout fans in person. So.
Now, today you are, I feel like a broken record saying this, you are joining us from a slightly different location. We've been very mobile with the show recently. We've done it in all kinds of places. So we're not in the Dome Observatory today. If you're in Chicago, I think you probably know why that is. Lots of snow, crazy weather, tons of clouds. We didn't want to suffer through all of that just in our telescope views tonight.
Right.
So we are here inside of the Adler Planetarium today, and it looks like we've got some folks joining from some similar areas, but some further away ones tonight. We've got folks in downtown Chicago and in Naperville, but also joining from Northern California and Southern California and Los Angeles.
Hello. Oh, we got Mokina.
Classic Mokina in the chat.
We know who that is. Hi, Bob. And so we've got our Sky Observers Hangout fans. Please keep putting where you are tuning in from in the chat. We'll keep saying hi to you as the night goes on.
And of course, make sure to post any questions or thoughts that you have throughout this. You know, the real benefit of being a live show is that we love that conversation and getting those questions from you guys while we're here and can answer them. So let us know if you have any of those throughout today. Now, we are going to get started with our show today, and it's a little bit of a different one than usual. So we're actually putting our feet in the water on a slightly new format for the show, where we're going to go have a couple of kind of recurring segments. And we're going to start today with a look back at some current events that have happened within the last month in astronomy. So it's been a pretty big month. There's been a lot of stuff going on. And so it was honestly kind of tough to choose just what we were going to talk about. So we're going to start by going over some of those big news stories of the last month, starting with our spectacular interstellar visitor, 3i Atlas. Michelle, can you tell the folks at home a little bit about what 3i Atlas is?
Yeah, 3i Atlas is a comet from another solar system. It is the third, so the 3 in 3i Atlas. 3 refers to the third interstellar object, so that's the 3i. And then Atlas refers to the telescope that found it. So the telescope system that initially found that comet. So 3i Atlas is an interstellar visitor, which is really exciting.
And one thing I want to mention with that Atlas telescope is that this is a kind of fairly new style of telescope that are these survey telescopes. So that means that it is surveying large areas of the sky, very different than what you might think of with a traditional telescope that's trying to peer into one small area, look very deep in the sky. This is trying to get many big views of the sky over time so that we can look for these transient objects, things that are changing in the night sky. So this has greatly increased our ability to detect things like comets, new asteroids, supernovae, and other galaxies, right? It has given us the ability to see these things that are changing in the sky. So while this is only the third one we've found so far, I do anticipate that survey telescopes like Atlas and some of the other really big ones that have been getting built all over the world right now will greatly increase the number that we find.
Definitely. I would expect when the Rubin telescope is getting going there in South America, that will be just exponentially increasing the numbers of comets and asteroids and all sorts of things that we find just in general. And then now that we've got some experience, the astronomy community has experience finding these interstellar objects and we know what to look for, then I expect we're going to find a few more. And we've got a few more folks who love 3i Atlas as well. So we've got folks tuning in from Salt Lake City, Ontario in Canada, Wheaton, Illinois, Washington, D.C., and you just visited the Adler this weekend.
Nice.
Thank you
Maybe
so
a little
much.
Thanksgiving traveling.
Yeah.
Thanks for coming to see us. Hope you had a great time.
Yeah, hope you avoided the snow.
That's true, yeah. I hope you were here on Saturday. Though if you were, great place to hang out inside and enjoy watching the snow outside.
Exactly.
Well, thanks for joining from so many places all over the place. We did have one question in the chat that I wanted to get to here briefly. Has the telescope at the Adler ever discovered something new in the sky?
Something new? No. Has it contributed to knowledge about objects, and have we done something that maybe might help confirm an object?
Right.
Yes. So, so what we're talking about is the 24-inch telescope that we have in the observatory. And the telescope that we have, we can use it for eyepiece observing. So if it's clear out on a Wednesday evening, which unfortunately it won't be tomorrow night, but that's okay. We're going to keep an eye on the sky.
Lots of Wednesdays to come.
Lots of Wednesdays to come. So when it's clear out, you can put your eyeball up to that telescope and see what we're looking at. But we also have been using it for research. And earlier this summer, we had a couple of our undergraduate interns take data on an exoplanet transit. So that would be an exoplanet that passed in between us and its home star. And it dipped the light from the star just a little bit. We were able to detect that. And the data we felt was good enough to upload to a database, which then other observers use to help confirm whether this actually is an exoplanet or not, because this is not a confirmed exoplanet. So hopefully our data will be usul to the astronomy community.
Capable of some useful research, but
For sure.
I would also say that some of the reason it hasn't discovered something new in the sky is about time spent looking for new things. It's not something that a lot of people are doing with their telescopes, if I'm going to be honest. Something like Atlas is using computer automation to search through these images to look for these things, but there is the chance of that happening. Some amateur, well, I call them amateurs, but they're very, very good at what they do. Astrophotographers have discovered some very faint nebulae in the sky through their images. There are also, if you go back and watch one of our past shows, Gazing at Galaxies, we talk about a supernova that was discovered in another galaxy, which was discovered by a Japanese amateur astronomer who would go and specifically look for these supernovae. He would observe galaxies repeatedly over time to try and spot these things. So there are ways that small telescopes can make new discoveries. And hello to our friends at Ann Arbor.
Oh, raised in Chicago and used to catch smelt at the planetarium. We see those smelt fishermen basically all year long.
They are out there all the time. I couldn't believe they were out there like last week. It was cold.
Yeah, it was very cold. So yeah, if you don't know what smelt are, that's like a uniquely upper Midwestern thing. These little tiny fish that you fry and you eat the whole thing, and they're really, really good. And so yes, If you don't know smelt, come to Chicago and give it a try. But getting back to our telescope.
I was going to say, should we change the show to Smelt Observers Hangout?
Observers Hangout. That would be awesome.
All right, we should talk about Three-Eye Atlas a little bit, though, because it is very interesting.
Yeah, so it's unlikely that we're going to discover something new, but what a telescope like ours is really good at is following up on
these
things.
discoveries that these big observatories are making. Yep.
Exactly. So the big observatories will stare at something for a little while, and then they got to move on to something else. And so we can go back and use our telescope to go and study these things for much longer periods of time. So we're pretty excited about the future of our telescope.
Right. Now, I want to talk a little bit about some of the pictures we have of Three-Eye Atlas here, because they kind of help us with guiding through the journey that it's taken through the solar system. So on the top left is a very early image of Three-Eye Atlas taken by Hubble immediately after Atlas discovered this object, and it was determined to be interstellar. Basically, every research telescope in the world is trying to find time to look at these things, even ones that are very competitive, like Hubble, James Webb Space Telescope, things like that.
Yep.
So that top left one is a very early image of Three-Eye Atlas. And, it didn't really come super close to Earth during its early trip through the solar system. So its close approach to the Earth will not be until, just about 2 weeks from now. It's on December 19th is when it'll make its close approach here. But first, it passed behind the sun and then came close to Mars, which is where these other two images came from. Mars was much more on the opposite side of the sun from the Earth and its orbit, and so we were able to get some more close-up images from some Martian craft. So the top right one is the Mars Reconnaissance Orbiter, a spacecraft that is normally looking down at the surface of Mars, but turned around to look the other way and imaged Three-Eye Atlas as it was passing by. And a really interesting one here, and something that I think helps us, talk about what we can learn from an interstellar visitor like this, is this spectroscopic view of Three-Eye Atlas from the MAVEN mission that is orbiting around Mars. Looking at the Mars' magnetosphere and why it lost its atmosphere. But it also turned around, looked at Three-Eye Atlas while it was passing to detect some of the things that are coming from the comet. So can you talk a little bit about what we can learn by looking at a comet like this? Obviously, this is a very unique one, being interstellar. So what are the things that we're trying to learn about this comet while it's here? And what can we learn from such a distance? It's not really getting that close to us.
Right, that's true. So that close approach is on December 19th. But we're close means about 170 million miles away. So it's not going to get any closer to Earth than that.
Right. So for some context, that's, twice as far away from the Earth as the sun is.
Right.
And
exactly.
This object is at most 5 kilometers across for the nucleus with, a big tail, but relatively small compared to space. At
most about 3 miles across. So it could actually be a little bit smaller than that. But what we want to learn especially about comets and asteroids, is what are they made of? Because this is a comet from a different solar system. Are comets from other solar systems made of similar stuff, different stuff? Are they made of the same amounts of stuff? Probably not. So the composition of materials in what that formed our solar system was probably a little different than what formed this comet. So we have found water ice, carbon dioxide, carbon monoxide, nickel, iron. So this is stuff that we do find in comets here, just not in the same abundances as we find here. But you think about it, you go, okay, it comes from someplace else. It's not going to be exactly the same.
Right.
So the fact that it is a little bit different, that's kind of to be expected. So that's pretty cool.
So one thing that has been kind of interesting about it as well is that after it was determined, the way that they determined that it was interstellar is by looking at the orbit it's on, its trajectory, and seeing if that orbit is eventually going around the sun, right? Many of these comets in the solar system, and really most of them, have these extremely elliptical orbits where sometimes they're very close and going fast, and sometimes they're really far away and going slow. And so we had to make sure that, even though it's not a perfectly circular orbit, that it is interstellar. And so they are looking at the orbit, the path that it is taking through the sky, figuring that out. And one thing that's interesting about this one is that it came from the direction of the Sagittarius constellation, connecting to our astrology theme for the show today. But that also is kind of towards the core of the Milky Way in the sky. So there's a chance that this could be something that is coming from a very old solar system, something that predates our sun and the Earth, right? and it makes it an interesting one to study to maybe learn a little bit about what the universe was like before anything was here in this neck of the woods.
Given the speed of this comet and its trajectory, it has been traveling for an extraordinarily long time. We're talking like billion with a B years.
And I think the quantity of dust that it has released, the anti-tail that's been visible, is evidence of a lot of time just in interstellar space, all frozen. Certainly been, I would guess, a pretty lonely journey for the comet.
I would imagine, because the space in between stars is vast and quite empty. Not totally empty, but quite empty. And so it's even at the speed that it's going, it still takes just an extraordinary long time to get from one solar system to another, and it's just kind of passing through as it makes its journey.
Now, the last thing I want to mention about this, since I know a lot of people ask it, is will we be able to see 3i Atlas? Will this be a big comet in the sky? Most of the comets that you will hear about on the news and things like that will be ones that are going to be visible to us. This one has been in the news because it's interstellar.
Right.
So this one, you won't be able to see it in the night sky with just your eyes, but some big telescopes could see it. It will be a very faint, fuzzy star-looking object, a point of light. So not a big dramatic one that you would see in the night sky, but very interesting for its research purposes primarily.
If you would like to see pictures of 3i Atlas or other comets that are in the sky right now, just not getting a bunch of news, you can go to spaceweather.com and go to the real-time comet photo gallery and peruse the pictures. And there's people posting pictures all the time. And so I would recommend doing that. It's pretty cool.
Well, the next thing I want to talk about in our current events was a dazzling aurora display. A lot of times for aurora current events, it would just be for the local area. This is like for everybody in the United States for this one. So these were northern lights that were incredibly visible. This was a big outburst on November 11th, I believe. Was that the right date? It's either the 11th or the 12th. I might have forgotten to put it in here. Sorry. Huge outburst that was visible, not just in Chicago, but we had some coworkers.
All 50 states.
All 50 states saw it. Really, really incredible display of aurora. Unfortunately, I missed it. Thank goodness. Michelle was there to take the lovely picture in the top left. We've got a few of our coworkers here. So Bella, who's in the chat tonight, took the one in the bottom right. And if I remember correctly from the messages, Bella's first aurora sighting. So very exciting. I love the one from Mike that shows it over the city. Even with the lights of the city in his camera, you could still see these aurora in the sky. And then a lovely fan of the Adler who was out here observing Chelly Pan observed it and took a picture of it behind the dome, and that's just stunning. So I would love to hear in the chat if any of you guys got to see these aurora a few weeks ago. It really was a pretty spectacular display.
Yeah, tell us, where did you see it? Where were you? What did you see? Did you see it with your eyes? Did you see it just with your phone? So just let us know. We'd love to know those comments.
Right, so I know the next day there was some that were spotted with just phones. I know Dylan got a picture of that one from here at the Adler. It was one of our Wednesday nights, and he was able to get a snapshot of it, but not visible to the naked eye. But that Tuesday, it was, everybody in the city was seeing it.
So that Tuesday night so my picture is on the upper left. That one was taken on Tuesday night. And
I think then maybe all of these are from Tuesday night. Potentially.
I think the one,
maybe top right's Wednesday.
I think top right was Wednesday night. Yeah.
But can you explain to folks at home, how did these happen? Why are we talking about this? What does this have to do with astronomy?
Yep.
Right? What's going on out in space for this to be possible?
This crazy atmospheric phenomenon, what's going on that connects to space? So we have a lot of activity that happens on our sun. So these types of solar activity include things like sunspots and flares and coronal mass ejections. And so what we've got up on the screen is some images of sunspots. So those are the pictures are on the left-hand side. Sunspots are areas where the sun is a little more magnetically active. The material of the sun just kind of sits there, gets all kind of bottled up and cools off. And so that material appears darker in our pictures. So those are sunspots, magnetically active areas. Sometimes these magnetically active areas can burst, and so we call that a solar flare, and that's a release of energy out into space.
If you watch the video that's playing on the screen, so that top right corner, that really bright white area is this sunspot group, and you'll see it with a huge pop of light. There it goes. Just incredible, the power of one of these.
And then if material is released as well, that's called a coronal mass ejection. I trip over those words a lot, so CME is what we often say. But coronal, it goes out into the corona, the outer atmosphere of the sun and farther. Mass, it's material. Ejection, it's ejected out into space from the sun. And so this material, if it's coming in our direction, it then will, of these charged particles, protons, electrons, they'll interact with Earth's magnetic field. And then protons and electrons start streaming toward Earth's poles. Now, if this is a particularly energetic coronal mass ejection with a lot of oomph to it, it'll cause the Earth's magnetic field to really get disrupted. The more disruption that happens, the farther south then we can see the auroras. And so this set of auroras on that Tuesday, was that the 11th, I think?
Yeah, it was the 11th.
So that Tuesday, the 11th, that was such a strong interaction with Earth's magnetic field that auroras were seen as far south as Central America.
Right. And that's all, the strength of that interaction is also what helps create these red aurora that we saw, which are not quite as common. So we had a pretty big auroral display in May of 24, but those that showed a lot of different kinds of aurora, especially different shapes that they can take. There was some coronal aurora above Chicago, but those were pretty much all green. This one, you can tell, was very energetic because of that bright red aurora that was even visible to the naked eye, I believe, right?
Yeah. So the people often ask, why am I able to see them? I see part of it with my eyes, but maybe just with my phone. I'm seeing some of the comments. And,
I know.
Oh my gosh,
I'll bring them up in a second. They're great.
Yeah.
I was reading them while you were talking.
Oh,
so
yeah. So we
you can finish your thought.
Yeah. So the green ones are the ones that are most often visible. That is from oxygen from about 60 to 180 miles up in our atmosphere.
Mm-hmm.
The red ones are a higher altitude than that, also from oxygen, and that's oxygen that's glowing. It's giving off light, and so this interaction between these charged particles and the oxygen causes light.
Mm-hmm.
And so in this case, green, or a higher altitude, red, but your eyes are not that sensitive to red.
Right.
And
so not only is it harder for it to excite those in the upper atmosphere,
Exactly.
it's also harder for us to see them.
Exactly. That's why you're more likely to see it just maybe with your phone camera. But this one, oh my goodness, I actually found it easier to see the red than I did to see the green.
I'm so mad I missed it, man. I just got back from a trip that day. I was so tired. I was just on my couch too. I totally could have gone and seen it. I wasn't doing anything.
Next time.
Next time.
But this one, the red was at times just really vibrant, and the green, I could definitely see where it was. It just wasn't a vibrant green to my eyes. But your eyes are more sensitive to green. So the fact that I could see it at all was great. And then you could actually see the red kind of pulsating in and out. You could see the green kind of moving in waves a bit. It was really cool just to rub it in a little bit.
If I had missed the one before, I would have been more upset. But I did get to see the one before.
There were some other colors that were visible. I personally didn't see them. I believe Geza mentioned seeing blue, possibly
That's crazy.
purple or pink. Geza, if you could put in the chat what colors you saw as well through your phone.
Very cool.
But blue and purple are from nitrogen, but that's from a lower altitude, so less than 60 miles up. And then sometimes you might see pink or yellow. And those are from I'm going to make sure I read it right.
The layers kind of blending together almost.
Red and green light mixing produces yellow. Red and blue light mixing produces magenta, pink. So you sometimes get to see these really interesting colors that you wouldn't normally see.
Mm-hmm.
Sometimes people see orange, and that's also an overlap of red and green, just probably a little, I'm going to guess a little bit more red.
A little more on the red side.
So, yeah.
Great question. So I did want to go back and hit a couple of anecdotes that we had heard. People in Northern California, lots of people say they saw purple there. Somebody from Northern California that at 67 years old got to see their first ever aurora, and that half of the sky was red there. So regardless of clouds, you're going to see that. I mean, it really was so much that people were spotting it through some clouds even.
Yeah.
And then I'm going to give a shout out to Bella's grandma too, and 92 years old, saw it for the first time and said, "It didn't just make my day, it made my life."
Oh my goodness.
How sweet.
Wow.
That's wonderful. So I think it was a really exciting opportunity for a ton of people, and thank goodness we live in a world where it's easy to get the message out quick, and tons of people were able to see this. I mean, it lasted a good few hours of this. So
well, we hope we get to see some more.
Yeah, that's the next question: is can we expect to see more of these? So
possibly.
Maybe. These are very, very hard to predict. So that's the first thing that I want to say is we don't know these are going to happen until they are happening. If I'm going to be honest, we can predict a couple days out, and those predictions will get more and more accurate as time gets closer. But it is very important to note that it is really, really difficult to make these predictions.
Right.
What we can say is that on here, we've got two different images of sunspots. I tried to match them pretty similar to scale. The text size is the same scale on all these images. I got them from the same source, from the Solar Dynamics Observatory. Actually, this was from Space Weather as well, but they pull the images from there. So that top image is the sunspot group that was responsible for the November 11th outburst. The bottom image is from today. It is a monster group coming our way. Absolutely huge. It's already been very active. And so that will be Earth facing here, and within the next few days, up to a week or so.
They call it geo-effective, meaning any flares that produce and that also produce coronal mass ejections, there could possibly be an Earth-facing component of that. So that could possibly happen. Hasn't happened yet. We're keeping an eye on it, but yeah, for maybe the next week and a half, we're going to keep an eye on it. And also what's not on this screen is there's another sunspot group that is a little bit farther north, I think. Anyway, a little farther away from this sunspot group, and it produced an X-class solar flare yesterday, which may have a graze, a coronal mass ejection graze to our Earth's magnetic field the night of December 3rd into the morning of the 4th. So will we see anything? Don't know. They're not predicting a really strong effect, so probably folks in farther north locations might see it.
All good stuff to keep an eye out for. We've been giving them a lot of shout outs tonight. Check out Space Weather. They will send out alerts for that kind of stuff. It is a great place to get aurora updates.
Definitely.
And it's very possible here. Last current event is just a quick launch that we wanted to cover because it is kind of an exciting one. This is the recent Blue Origin launch that sent the Escapade mission to Mars. The mission is interesting on its own, but first I want to talk about the launch because this does make Blue Origin only the second company in history to be able to re-land a booster component. So that means that they are launching the craft into the air, sending their payload into space, and then re-landing the booster back on Earth so it can be used again. So very big revolution in space.
And that's the point, is the cost of launches will come down as portions of rockets get reused. Why? Well, not why. One of the reasons why spaceflight is expensive is a lot of times these things are single use. And so you send up a rocket, the pieces come down and break up and you don't ever do anything with them ever again. But if you can safely land a booster, you can refurbish it, use it again. And so SpaceX has been doing this. Now Blue Origin has the capability of doing this.
And so the other two pictures that I have in here are of the Escapade mission itself. Well, the bottom right one is a bit of a selfie. It's one of the spacecraft taking a picture of the other spacecraft in visible light and looking to see where everything was getting hot. But up in the top right, you can see those kind of twin spacecraft. I think it's sort of a fun mission that has these two paired together that will start orbiting together around Mars. Tracking these small changes in the Martian magnetosphere, investigating the solar wind's impact on Mars's atmosphere. Really a lot of similar partnerships with the Maven spacecraft that we talked about earlier.
Yep.
And then we'll separate later on in their journey and occupy different areas of Mars's orbit to see how things change on a bigger scale.
Yeah,
so it's an interesting mission.
Yeah, it's kind of a concept that has kind of been used before with the MMS, Magnetosphere Multiscale Mission, spacecraft orbiting Earth, and so this is now taking kind of a somewhat similar concept to Mars with 2 spacecraft called Blue and Gold, and those are the colors of UCLA, which is where the spacecraft came from.
Nice. We did also have a kind of an unrelated question. That was kind of all the stuff on the Blue Origin flight, but a fun one to look out for. The baby moon, the asteroid that was orbiting around the Earth, micro moon, whatever you want to call it, little rock orbiting around the Earth temporarily. Has it been observed by Adler telescopes? It has not. I'm not sure how bright it is, if I'm going to be honest. It might be too dim for us to even image, if I remember correctly.
It is.
Our limits are probably around, for those that are familiar, maybe around magnitude 17 or 18 on a really good day. I think it might be even dimmer than that. It's a really, really tough one to see, and would take a very, very, very large telescope.
It will not affect the orbit of our moon to a noticeable degree. However, it is a good point. The gravity of the mass of something, so if you have mass, you have gravity. The bigger something is, the more mass it has, the more gravity it has. So the gravity of our moon and our Earth affects this little tiny rock, but it does have a little gravity. It does, well, you could calculate the gravitational effect
I don't know if it's
on
really
our
gonna...
moon. From a practical sense, it will have no effect on our moon. Nothing noticeable, that's for sure.
And then one other comment, I will say this is a very current event. There was an accident at a launch facility in Russia that someone had mentioned in the comments. They actually are not capable of sending spacecraft into orbit anymore. Yeah.
I did not hear that.
I was like just maybe 2 days ago or something. It was like over the weekend. Yeah, I think something broke, clearly.
Obviously.
A very, very important part of their launch facility. So that is a big one. It was actually so recent that I didn't have time to include it in our current events section. So shout out whoever's in the comments. Really staying up with astronomy news.
Actually, if the person who put that in the comments, if someone could put the launch facility, the name of the launch facility, was it Baikonur? Was it the Cosmodrome? Or was it a different launch facility that is it the launch facility that launches people, or is it the launch facility that also launches spacecraft? Yeah.
I don't know. I don't want to share any misinformation, so we'll have to check on that. But yes, that is a very current event. And we'll take a look at that as you type it out. Thank you for your comment.
Yes.
Very helpful. This is the kind of back and forth that I like to see.
Love it.
So that concludes our current events portion of the show this evening.
All right.
So we did want to do a quick little what's up in December, kind of highlight some big observing things that are really easy for you guys to observe at home. So these are all things that will be very easy to see with the naked eye, don't require any big tools.
Oh, he said it is where they launched the ISS, the Soyuz-bound spacecraft. Ooh, that's not
That's what
good.
I thought. No, it's like...
Oh, that's not
They're like
good.
not doing anything for a couple years.
Oh,
is what I saw.
years.
I don't want to say anything wrong.
I
think I remember seeing 2027.
Wow.
Is how long it'll take to fix. So
that's not good.
No, it's not great for them. Or really anybody. Pretty tough.
All right.
I don't believe anybody was injured.
Good.
At the very least.
That's good
no
to know.
injuries.
That's
So what's up in December this month?
Oh, there's a lot going on.
There is a lot going on, and we won't highlight everything right now because we'll have the chance to talk about the sky later too. But we wanted to highlight a few things. First, in just a couple of days, another big full moon, and yet another supermoon of the year. And I want to bring this up just because I want to make sure that people know what this means, because it really does get a lot of coverage these days. So these supermoons are... We talked about elliptical orbits earlier. The moon is one of those, just like really everything else. Nothing's a perfect circle out there in space. There's way too much going on for that to happen most of the time. And so the moon has this very, very slightly elliptical orbit. That means sometimes it's further away, sometimes it's closer. A supermoon happens when that closest approach lines up with a full moon.
Yep.
So we can oftentimes see the moon at these larger sizes, but it's when that close approach lines up with the full moon. So it can make it appear a little bigger, a little brighter in the sky. You probably won't notice a big difference, but if it means that you'll get outside and appreciate the moon that's always above us, then that's a good reason to get outside. Am I right?
I tend to notice the brightness more than the bigness.
Me too. I will say that I feel like I always am like, nah, you won't notice a difference. I'm like, it does look pretty bright tonight.
Yeah, brighter.
Yeah.
It'll look a bit brighter. The size difference, there's nothing else to compare it to in the sky, so that's pretty hard to tell. It's at most maybe 10% bigger.
Yeah, I think it's like 10, 12, something like that. It depends on the supermoon.
14, somewhere around there. So that's really hard to tell.
Right.
But the brightness,
it's more like, I think, a 30% difference from the smallest the moon can be.
Yep.
So worth getting out. I will say, I think the last one I was out at the Dome on a Wednesday night when it was happening. It was the full moon night. Was really bright. I remember noticing shadows on the ground from just the moonlight that were like pretty well defined. So worth checking out. It can be quite dazzling, especially along like the snowy ground that we got here right now.
Exactly. So the December 4th. So as the sun sets, the moon rises. So look for it on Thursday night.
And then coming up on the 13th, and really kind of throughout the month of December, but the peak is on the 13th, taking up much more space here because it's much more exciting to me, the Geminid meteor shower. So there's a lot of meteor showers throughout the year, but this is one of the best ones. This is like your prime wintertime meteor shower, and the Perseids in the summertime are great, but the Geminids are really, really wonderful for the winter.
Geminids are even better.
I do think so. You might have a better chance of clouds in the wintertime.
That's the problem.
But if you get a clear night, they are really, really spectacular. These can produce upwards of like 100 to 120 meteors per hour from very dark skies. If you're here in the city, you won't see nearly that many, but there will be some very bright ones. And, last year I was also out at the Dome for the Geminids, like right around the peak. And I saw like a dozen that night without like really paying attention to it, like while working and talking to people. So it's worth checking out for sure.
And that's another great thing to mention is you were out at the observatory right around, it was about 8, 9 o'clock.
Right, so this would be like 8 to 10, kind of around prime time, a little early.
Exactly. Yeah, for the Geminids, meteor showers are generally best visible after midnight, but you can start looking for Geminids around 9, 10 o'clock at night.
Right.
And so I vividly remember Hunter mentioning the Geminids last year because people were noticing them all over.
I mean, we saw so many that night, which was really fun to be able to enjoy that together. So nice thing with meteor showers, you don't need any extra equipment. This is really great for somebody that's very new to observing. It's actually a detriment to have equipment. You want to be able to see as much of the sky as possible. So we always tell people, set up in a comfy place that's pretty dark and away from lights. If you've got any lights near you, maybe have something blocking you in those lights, like street lights, maybe put a building between you, so your eyes have more time to adjust to that dark sky. And then it's really just all about laying back and relaxing. You'll want to look to the eastern sky for this. You can start, earlier in the night when Gemini will rise. The Gemini constellation will rise around 7 that day. But the later you get, the better chance you have of seeing some of those meteors. And that's great to watch throughout the night, really. So you just look to the east, find Gemini. You'll have the kind of twin stars. We'll see the map later. I'll explain it more later, but it's really worth checking out.
You want to look for quick streaks of light, and where the name Geminid comes from is if you trace all the little trails back to where they radiate from, they appear to radiate from the constellation Gemini. Are they actually? No, but that's where they appear
it's the
to
part
radiate
of the
from.
sky. Well, really, in astronomy, when we refer to constellations, we are almost kind of referring to like a region of the sky rather than a place in outer space.
Right.
Because even all the stars in the Gemini constellation are not together.
Correct. But it's kind of like when you're driving down a street and you're driving into a snowfall and all the snow appears to be coming at you from one point. Is the snow coming from one point? No, but it's
coming from above.
It's all your perspective as to how you're encountering that material.
It's a good comparison.
Yeah.
And just a little fun tidbit about the Geminids. The way that meteor showers happen is that it is debris, dust in space that the Earth is passing through as it orbits around the sun. And as those hit our atmosphere, they have all this new friction, they burn up, and those are the shooting stars that you're seeing in the sky. The reason that meteor showers happen is because we're passing through the dust trail left behind by more often a comet, but with this one actually an asteroid. So this is one of only 2 that has a parent body that is an asteroid, 2 of the major meteor showers.
If any of you in the chat have seen the Geminid meteor shower before, because it's probably one that not a huge number of people have seen, mainly just because of the time of year, because
Right.
it can be cloudy. Hey, where were you? What did you see? How many did you see? Let us know. So let us know in the chat about your Geminid meteor shower experiences, or any meteor shower experience for that
it's always a
matter.
fun
So,
time.
yeah.
And when it's clear out in the wintertime, it's really clear, and you can catch a lot of good stuff.
Yep.
You get really nice, calm skies. Very good seeing in the winter. Last thing I'll mention is winter solstice is coming up on December 21st. Longest night, lots of time for observing. So, I know for some people they might not be super excited about a really long night and a really short day, but for astronomers, what a thrill. What a thrill. Well,
Yep.
after that, days will be getting longer.
Yep.
Don't worry, but still lots of time to observe.
Exactly.
All right. Now, for our next section, we wanted to talk a little bit about some new stuff going on here at Adler, which connects to the main topic of the show that you have probably seen from looking at the title today, looking at astrology and the constellations of the Zodiac that are in the night sky this winter. And the reason we're talking about that is because of this new exhibit that just recently opened at the Adler called Stars Aligned. So what can you tell folks about what Stars Aligned is all about? I know you were on the project team.
Yeah.
I'd love to hear that from you.
It was such an interesting project because it is all about the connections between astronomy and astrology in the early modern period. So that time period of approximately 1500 to 1800. And so at that point, yes, you were starting to get the science of astronomy separating from astrology, but astrology was still playing a major part in many people's lives. And so seeing those connections, what did people think? What did they think? How they connected the sky to their everyday lives? Because back then, today we think astronomy. We think, oh, the sky. Oh, it's that stuff up there.
Right.
Well, it was everything around you included the sky. And so people wanted to make sense of the world around them. They wanted in an era when you had early mortality or a lot of mortality, a lot more maybe than we have now, you kind of wanted to get a sense of what the universe had in store for you. So trying to figure out those signs, those signals, what clues were in the universe, in the sky above, trying to find those clues and decipher them.
Right.
That's what this was all about.
Yeah, give some reason for things. They've got that big sky above them. I mean, really it occupies half of what you're looking at. Half of the stuff's down on the ground, the other half's up in the sky. So giving reason to the things that you see, I think, is very fair. I think one other thing is that we also these days kind of take for advantage the easy accessibility of information. And so in astronomy, this can be represented by very detailed, precise measurements of where everything is in the solar system and where very particular locations of where these stars are in the sky. Back then, they were having to measure all of those things by hand and really track these throughout the year. And so that's another way that astronomers and astrologers were connected, is that the astronomers were out there mapping the skies. That was a lot of the work that they did. And the astrologers were using that information to bring meaning to the things that they were seeing in the sky.
And not only that, sometimes those were the same people.
Right.
So astronomers who I know our audience has heard of were also astrologers. Galileo, Kepler, Tycho Brahe. These guys were astronomers. We would think of them as astronomers, but they were also trying to, they would cast horoscopes and try to decipher the meaning of what was going on, those measurements that people were taking or that they were taking, and try to come up with the reason behind all that.
Right.
So yeah,
that was a
pretty
moment for
fascinating.
me when going through the exhibit that I was, it felt like a meaningful moment while reading through everything, was seeing the desk in there that has some of Kepler's writing on it.
Yeah.
There.
He
And it's
kept-
him talking about not only a horoscope reading, but something about his sun.
Right.
That he is using the stars to, try and figure out what his son's going to be like when he grows up. So it's something that he takes very seriously, respects, and really cares about. And that's coming from somebody that we know as being really, really, really instrumental in the history of astronomy. So I think that really helped enlighten me to just how closely connected they were in the past. and that kind of shared history that they have.
Yeah, and so it was also a way for these astrologers to supplement their income, was to cast horoscopes for people. So what would their lives mean, what an auspicious day might be for something to occur, if something was happening in the sky, what did that mean? So yeah, it was all connected. So if you want to see a bunch of really cool stuff that we've got on display from our collection, including several things that we have never put on display before, including
Is that almanac scroll one of the objects that has never been displayed, right?
Correct.
So it's a Hindu almanac scroll, very similar to some of the things that Kepler was doing. These almanacs would be a big list of the significant locations and timings for things throughout the year that would be used in guiding the decisions made for significant events. When you would get married, when you'd go talk to an important politician about something, all kinds of different important meetings in life. And so it's a great chance to see some really new objects. I hope you guys come out and visit us here at the Adler and come and see it.
It's called a pachanga. It's beautiful. It's absolutely beautiful to see in person. So please come and see all that. We had a comment, I cannot believe they were able to predict eclipses so long ago. You're right. It's astonishing to think what people were able to do with the limited resources that people had to do math, which was pen and paper.
Yep, writing it all down.
Pen and paper and tools like astrolabes and other things to be able to make observations and do calculations. But yeah, absolutely, I completely agree with that commenter.
Yeah.
So yeah.
It's that information we take for granted these days, right?
Yeah.
Well, since we're talking about stars align, we wanted to talk a little bit. Of course, this was hoping to be our observing portion of the night if we were out in the dome today, but we're still going to talk about how you can observe, because hey, you're in Northern California. It could be clear there right now, Jeff. I'm not sure, but places all over the place, so you guys might be able to see some of these constellations tonight. So we are going to talk a little bit about it. We'll talk about the night sky and some of the objects you can find in these constellations, but we will focus primarily on the constellations of the Zodiac that are in the night sky right now. So I've got something pulled up here called, this is Stellarium Web. So this is a really fantastic online sky chart where you'll see this is a very live view. We've got the exact time right here for my location. Live view of the sky from where we are right now. I really like this one because it has a ton of features and is totally free. They have an app too. I highly recommend it. It's the one that I always use because they really, for not costing anything, they have a lot of stuff available in there. And so this is our view of the entire sky right now. And really this is kind of helpful even when we're out in the dome because we see such a limited region of the sky there. One thing that you'll notice is I've got this red line across here right now. This is something called the ecliptic. Can you explain what the ecliptic means, Michelle?
Yep. So our solar system happens to be pretty flat, and so all the planets will orbit in orbits that are relatively flat. And so as we see it from Earth, the locations of where the sun, the moon, and the planets appear to travel in our sky is along that flat line, and so we call that the ecliptic. And so this is where you'll find the sun, the moon, and the wandering stars. So the fixed stars, to use a term that the astronomers would have used, the fixed stars are the ones that are in the background. The wandering stars, called planets, are the ones that move. And for the purposes of the Stars Aligned exhibit, for the purposes of astrology in the past, the sun and the moon were also considered to be those wandering stars, those planets. So we now call, we have a technical definition for a planet
right.
these days. It's a different definition.
And so the reason that ecliptic is important is, well, not just because it's the plane of our solar system, but for this discussion today, the way that these constellations were determined as constellations of the Zodiac is that they fall along that ecliptic path, right? We have the solar system objects passing in front of them. And I think this is really important to note because it means that these constellations aren't necessarily special because they're easy to see. It means they're special because of where they are in the sky.
Correct.
And so this is a very important thing to note with some of these, is that especially here in the city, you might be able to see 1 or 2 stars in some of these, maybe none for some of these. So if you haven't seen all of these, and then if you go outside and you don't see 2 big fish leaping out of the water, it's because the stars in Pisces are really dim.
And don't worry, I haven't either, so it's okay. Totally fine.
So we'll talk about the big view of the sky tonight and all of those constellations we can see right now, but then we'll have some specific, advice for which ones are more visible, what are some of the really interesting objects we can see in these. So of course, all the way here on the western side, this is where things are setting in the night sky, right? And so that's where we see, we'll hit those first because they'll be setting soon here tonight. Capricorn, Aquarius, and then the Pisces that we were talking about. Pisces and Aries, all 4 of these pretty dim constellations.
Very, yes.
Especially with the location of the moon right now, it's going to be very hard to see Aries. But even with the moon out there, I think you would have a pretty tough time spotting any of these. What I will say, though, in guiding you and looking at these tonight, is that right smack dab in between Pisces and Aquarius, we do have Saturn in the night sky. So it's actually kind of nice because Saturn's really empty. It's almost alone in the night sky right now. There's like nothing around it. So if you look due south, if you go outside right now, you can see it in the sky there. And you'll see, you'll at least know where these constellations are, but you will not see them.
Yeah, basically, if you're not sure you're looking at Saturn, trust me, you're looking at Saturn.
Yep, there are no stars anywhere near it right now.
It's about halfway up in the sky. There's nothing else around it that's that bright. So yes, you're looking at Saturn. And the pictures at the bottom are 2 pictures that we have taken using the telescope out in the observatory. So this is kind of what it looks like.
It's not far.
If you put your eyeball up to it, actually, if you put your eyeball up to it, it can look even better than the pictures that we have. All these pictures that we always take are time exposures, so extended time. And so they tend to get a little fuzzier because we're taking them for some fraction, a little bit longer than a fraction of a second than what it takes your eye to refresh. And so those pictures are going to be slightly fuzzier. It'll be even a little bit more crisp with your eyes.
Absolutely, yeah. One thing I will say, though, is you will not get this kind of a ring display from Saturn right now.
Not right now.
Those rings are almost perfectly edge-on. It's actually just like a funny little line cutting Saturn in half at the moment. So that's how you can tell these pictures are a couple of years old at this point.
Yep.
It sounds like it might be time to go do some Saturn picture taking, get some updated ones.
We need it to be clear.
That's true. And so Saturn can help you guide in seeing these constellations in the sky right now. Now, moving on from these 3, we'll really get into some of the ones that I think are much more visible in the sky. So actually, if we go back to the stellarium view really quick here, we have the next one that I want to focus on, and that is Taurus here. So this is one where you can see like pretty much the whole constellation is very visible to the naked eye. You can see where it appears right now, very close to the moon in the sky, and I think somebody in the chat mentioned that the moon is going to occult the Pleiades tomorrow night.
Can we show that?
Actually, yeah, of course we can, yeah. I can't believe I didn't think about that. Boom, one day forwards, the moon is going to be right smack dab in front of it.
Zoom in on that just a little bit.
So an occultation in astronomy is when one object passes in front of another. So this is the moon passing in front of the Pleiades. This is one that happens fairly frequently, like a couple of times a year you can see the moon occult the Pleiades, but also sometimes it happens where the moon will occult a planet, which is really interesting, kind of a fun one to see through the telescope. But there you go, that's something that you can see tomorrow, and a good demonstration of just how much the moon does move across the sky in just one night. Right?
Exactly. And the moon will move from one night to the next. If you're facing it, it will move a little bit to the left or a little bit more toward the east. And so as it's going around the Earth, you can actually see this one night to the next.
There it goes. There it is on its full moon. And it'll be just right in between Auriga and Taurus.
Yep.
So some things that I wanted to highlight in Taurus that are really quite dazzling. One thing that it kind of specializes in is star clusters. So we have this beautiful one that makes up here. I can turn on the images there. The head of the bull here, this triangular shape that we have there. How do you pronounce it? Hyades?
Hyades.
Is that right? Yeah. Okay, just wanted to make sure. Hyades star cluster. These are all actually, this is one of the rare situations where a bunch of stars in a constellation actually did form together right around the same time, is the Hyades star cluster, as well as that beautiful Pleiades that we talked about. So that's another one that we saw in those images, and very, very common astrophotography target is the Pleiades because of these beautiful kind of nebulous clouds that you have around the outside. Something that this is a significant star cluster throughout history, and one where it really is quite striking when you notice it in the sky. We can see it from here at the Adler when it's out to the east, so there's still a fair amount of light pollution here. It's not too hard to spot, and they really are super tightly clumped together. That's what you'll want to look out for. They're really close together, but quite striking to be able to see like a tight star cluster like that with just the naked eye.
It'll look like a teeny tiny Little Dipper.
Right, exactly. You might also be familiar with another name that it has, Subaru, the Japanese name for it. And if you've seen their logo, it is of these stars.
Exactly. It's also called the Seven Sisters. There's about 500 stars.
There's a lot of names that are very
group.
significant.
So you might see 6, 5,
Right.
10, 14. It depends on your eyes. And actually, the Pleiades in the past has been used as an eye test for people. How many stars can you see?
How many stars can you see? There you go. Good test for your light pollution level,
Correct,
too.
yeah.
And the other one I put, this was really just like I hope we can observe it tonight, because it's a very interesting object for a whole bunch of reasons. But the Crab Nebula that we had there is also in Taurus. This is really cool because it is a supernova remnant where the supernova has actually been documented. It was documented by Chinese astronomers in 1054. And really cool object. So that was because I really wanted to look at it with the telescope. I've never looked at it through the dome before. But unfortunately, that's how the weather goes, I guess. So
Next time.
if somebody holds me to it, I'll show you the Crab Nebula at the next clear show, I promise. Well, if it's up, of course.
Right.
So that's what we've got in Taurus tonight. By the way, let us know if you have any questions in the chat about things that you can see in the night sky tonight. So the last one we wanted to talk about is another very, very stunning zodiac constellation as far as visual observing goes, and that is Gemini. So we can see right here, it is very close to the horizon here, but this one really does have a lot of bright stars, especially Castor and Pollux. Those two, a lot of times they get called the twin stars because they are the Gemini twins, right? Very close together, very similar in brightness. They're really quite a pair in the night sky.
One of the things that Stellarium also gives you a good sense of is the faint color that you might see with these. So if you notice that one of them looks a little kind of tinged orange-ish.
Right, Castor's a little more blue colored, Pollux a little more yellow, orange.
Those are colors that you might see. You might see that in the actual night sky when it's a little bit higher up above the horizon. So yeah, check that out. This won't be a vibrant color, but it might be just a
It'll be dim, and you can especially know that on something like Betelgeuse and Orion, which we can also see in view here. Not a constellation of the Zodiac, but a very, very stunning winter constellation, and certainly one worth paying attention to while you're out there looking at Taurus and Gemini right together. I mean, that is a winter quadfecta if I've ever seen one. Those four all together, Taurus, Origo, Orion, and Gemini, are great constellations. I love the winter sky because of some of the really stunning shapes that it has.
But the other neat thing is there is a planet in the mix that actually can maybe, if you don't know how to find maybe Gemini, Jupiter can help you locate that. So if you see where Jupiter is.
Got Jupiter down here.
Yep, there's Jupiter.
Right
and
below it today.
Notice the size of the dot on the screen. In Stellarium, the size of the dot indicates the brightness of the object. A bigger dot on the screen indicates a brighter object.
Right, so you will not see other dots as big as Jupiter.
Correct.
Well, except for the moon, but that doesn't count.
But the Jupiter brightness is really bright, but just up and to the left a little bit is Castor and Pollux. And so if you've never seen Gemini before, just find Jupiter as in the brightest thing off to the east, and then look a little bit above and to the left. And there you will find Pollux a little bit closer and Castor a little bit farther. And so that's a way that I like to help people understand that if you don't know where stuff is, use something else to help you find it.
Especially something like these planets that are very bright and obviously visible.
Yep.
And while we're on the topic of Jupiter's position in Gemini, I think this also really helps hit home your discussion of planets as wanderers early. I grabbed some snapshots of Jupiter and Gemini's relative positions I started a month ago in the top left. Top right is today, bottom left is a month from now, and bottom right is in 2 months. And you can really see that position of Jupiter changing relative to Gemini, and having a very distinct constellation so close to it right now really helps you get a sense of that movement of the planets across the night sky, how those change over time, and really how early astronomers were able to determine that the planets were something different other than the stars, that there was something special about them. They maybe didn't know that they were other Earth-like objects, but they knew that there was something that made them unique. They were bright, they were all in this path together, they were changing positions against the constellations. So a good little homework assignment for everybody. Go out for the next couple of months, see how it goes from like a little curve together to much more of a triangle in just 2 months' time. Really not a big difference.
Yeah. So it's something that you're seeing the active movement of the Earth around the sun, and a little bit of the movement of Jupiter around the sun, although it goes a lot slower than the Earth. But thanks to the Earth's movement and Jupiter's movement, you've got the movement of both. You've got Jupiter's movement, apparent movement in the sky, and then you've got that with the rest of the planets as well that we can see. Can we go back real quick to Stellarium?
Yeah.
Because I wanted to point out one thing that I almost forgot. And so if you take a look at scroll in for the Pleiades.
Oh, yeah.
And notice where it says Uranus.
Oh,
see that?
yes.
Yeah.
They do appear very close together way back here.
I wanted to point out that because it can be very confusing if you don't scroll inward.
Right.
So what Hunter's doing is scrolling in, which is zooming inward. And so Uranus, you're not going to see it.
Yeah.
It's labeled, but it is extraordinarily difficult to see with just your eyes.
Most of the objects in Stellarium are labeled because they are bright and noticeable. The one exception is they put labels on all of the planets when they are in the sky. Uranus was is not easily visible to the eye. Technically, it's within the naked eye limit.
Yeah.
Technically. Very, very difficult to see, and a lot harder these days since we have so many lights all over the place.
Yeah.
So not going to see Uranus with the naked eye.
Nope.
But if you want to do some planet hunting, just as a reminder, Jupiter and Saturn, both pretty close by. I guess kind of spread out across the sky, but in the night sky altogether.
So hopefully if we get a clear night in the observatory this month, so it would either be next week, the week after. Hopefully one of those will be clear so we can check out Saturn.
Get the chance to observe some of this stuff. Yep, look at Saturn. Jupiter's starting to get high enough to see, so you should definitely come and see us out at the Dome Observatory if you're here. We're open on Wednesday evenings. It's Illinois Resident Discount Day. It's a very exciting time to be at the planetarium. We're open from 7 to 10 when we do have the Dome open during the winter time. Summer we got to push that a little later, but for now 7 to 10, and it's always free to come and check out the observation. We might have a long line, but you're always welcome.
The rule is if the door's open, come in.
Come on in. Yep, exactly. Otherwise, if you have any final questions or comments for us tonight, you're welcome to leave those in the chat. But we have hit all of our big topics for the night. It's been wonderful getting to join you all today. I hope you all have enjoyed the new format, jumping around a little bit more on our topics, but looking at things that are a little more time sensitive and relevant. We've done so many shows. This is episode 48 now. I haven't been at all of them. You have been at all of them. This is episode 48 now, and we have covered a whole lot of different subjects in Sky Observers Hangout. And so we thought, you know what? I think it's time to talk about what's new in astronomy and really focus on some of those things. So I hope you liked the format. Always at the end of the show, we say, hey, we're going to post a feedback form in the chat, and we do like reading that feedback, but it's extra valuable this time. I'd love to hear what you guys think about that new format. Put that in the any other stuff you want to say, any other thoughts on the show section on there. We would really like to hear that because this was our first time testing it out, and I hope it was an enjoyable experience for you all too, even if we couldn't be out in the dome tonight.
I love seeing all the comments and questions, and that's awesome. Great. We love that. And we definitely have gotten your comments and questions before, but it was really great that you're joining in with us.
Yeah, and I like when it's about those recent experiences that are still exciting for everyone, right?
Yeah.
lots of things in astronomy are very far away and a very long time ago, and sometimes it's nice to think about, hey, what happened this month?
Right.
So I hope you all enjoyed that format today. If you did, unless everybody sends us feedback and says that it was terrible, you should subscribe to the channel so that you can see future shows that will follow this format too. You can hit subscribe right down below. That'll show you future Sky Observers Hangout episodes, but also all of the other wonderful content that we put on here. And also, as a reminder, today is Giving Tuesday, so if you extra enjoyed the show and want to show your support that way, Bella will post a donation link for the Adler in the comments. We'd love to come see you out here. We'll post the link for tickets. All the links are going in the chat because we love interacting with you in every way we can.
And you can give us a thumbs up. That'll help other people find our show. That would be great. Like Hunter said, this is our 48th show. We've been doing Sky Observers Hangout now for just over 5 years. And so it's been a blast doing it. And so we look forward to many, many more, especially with interacting with you, because that is the most fun part for us.
Just wanted to say thank you for your nice comments. I'm glad that the astrology brought folks and that you're going to stick around for some of the astronomy in the future. Really happy to have you all here tonight. Other than that, any final words for them at home, Michelle?
Just come on, see us sometime. Come see us in the observatory. Come watch a future show. Come visit us at the Adler. We would love to interact with you in person as well as here online.
Alrighty, well, thank you all so much for joining us tonight. Have a lovely rest of your Tuesday, wherever you are out there, Chicago or all across the country tonight. Thanks so much for joining us. Have a good one.
Good night.